Right now, somewhere inside your skull, a tiny patch of cells is waiting. It is older than language, older than memory, older than you. And one day, without warning, it will flood your whole body with a chemical storm. Your heart will race. Your palms will sweat. You will lie awake at 3 in the morning, replaying one person's face. You will call it love. Your brain calls it something stranger. Because the same circuit lighting up when you fall in love is the circuit that lights up in addiction. The truth is, falling in love is not a feeling in your heart at all. It is a precise sequence of events happening inside your brain, in a specific order, in specific places. So let's open the skull and watch it happen, step by step. It begins in a place almost no one has heard of. Deep in the middle of your brain sits a small cluster of cells called the ventral tegmental area. It is one of the oldest parts of you, buried far below thought. Its only job is to make dopamine, the molecule of wanting. Not pleasure exactly. Wanting. The pull toward a reward. When you meet someone and something clicks, this little factory switches on. It starts pumping dopamine forward into a region called the nucleus accumbens. This is the same pathway that lights up for food, for money, for cocaine. Think of it as a spotlight in a dark theater. Normally it drifts across the whole stage of your life, but falling in love grabs that spotlight and locks it onto one single person. Suddenly, they seem brighter than everything else, more interesting, more important. Scientists have scanned the brains of people newly in love, and the ventral tegmental area lights up like a flare. The more in love they report being, the brighter it glows. This is why a new crush feels less like calm and more like hunger. Your brain has tagged another human being as a reward worth chasing. And once that spotlight locks on, it is very hard to switch off. But dopamine is only the first chemical in the storm. Because if wanting were all there was, you could simply walk away. So why can't you? Why does new love feel so physical? The pounding chest, the shaking hands, the stomach that forgets how to hold food. That is a second chemical joining the dopamine. Its name is norepinephrine, a close cousin of adrenaline. It is the same substance your body releases when you are frightened or about to run. So your brain, flooded with it, puts your body into a kind of high alert. Your heart beats faster to push blood to your muscles. Your pupils widen. Your skin tingles. You feel awake in a way coffee could never manage. This is why people in early love often cannot sleep and forget to eat. Their bodies are running the ancient survival engine, but pointed at a person instead of a threat. There is a strange overlap here worth sitting with. The racing heart of terror and the racing heart of attraction use almost the same wiring. That is why a scary first date, a tall bridge, a thrilling film can make two people feel closer. The body is buzzing and the brain hunts for a reason. It often blames the nearest interesting face. Researchers once tested this on a high, swaying bridge and found people there felt far more attraction than people on a safe, low one. The fear had primed the engine. This same chemical also burns the moment into memory. Norepinephrine sharpens recall, which is why you can remember the first time you met someone in vivid, almost painful detail. The color of the room. A single sentence they said. the exact way the light fell. Ordinary days blur together, but those early moments are etched in because your brain flagged them as important and turned up the recording. That is also why the loss of early love can ache for years. The memories were burned in deeper than most. So now your spotlight is locked, and your body is racing, and the moment is being seared into permanent storage. You would think that is enough chaos for one brain. But there is a third change, and it is the one that makes love feel less like joy and more like a beautiful kind of madness. Why can't you stop thinking about them? You try to read, to work, to sleep, and their face keeps sliding back into view. This is not weakness of will, it is chemistry. In early love, a chemical called serotonin actually drops. Serotonin is the molecule that keeps your mood steady and your thoughts from looping. When it falls, thoughts begin to circle and repeat. An Italian research team measured serotonin in people who had just fallen in love. They found it had dropped to levels seen in people with obsessive-compulsive disorder. Let that sit for a moment. The brain of a new lover looks, chemically, a little like the brain of someone who cannot stop checking a locked door. That is why you replay conversations, why you read one message 40 times, why a single person can fill your mind for hours, crowding out everything else. Your brain is not broken. It is doing exactly what this state is built to do, which is to fix your attention on one person until a bond can form. Evolution did not want you calm and reasonable here. It wanted you obsessed long enough to stay. Think of it as a search engine that has crashed on a single result and refuses to load anything else. Annoying, exhausting, and completely out of your hands. This is also why early love feels so much like a craving. The low serotonin and the dopamine hunger combine into something that genuinely resembles withdrawal. When you are apart from the person, you feel restless and incomplete, almost in pain. When you are near them, the craving quiets for a while, then returns. Brain scans of people going through a recent breakup show activity in the very same regions tied to drug craving and physical pain. Heartbreak is not just a metaphor. To your brain, losing a love can register a little like losing a substance it had come to depend on. But here is the part that should worry you. While your attention narrows to a pinpoint, another part of your brain is quietly being switched off. The part whose entire job is to warn you when something is a bad idea. You have heard that love is blind. It turns out that is not poetry. It is biology you can see on a brain scan. When scientists slid people in love into a scanner and showed them photos of their partner, two regions went unusually quiet. The first was a stretch of the frontal cortex used for judgment and criticism. The second was the amygdala, the brain's alarm bell for fear and doubt. So, in the presence of the person you love, your inner critic dims, and your alarm system turns down its volume. This is why early love feels so safe and so reckless at the same time. You stop running the usual checks. You overlook flaws that friends spot instantly. You feel certain about someone you barely know. Your brain has deliberately lowered the lights on doubt, so the bond can form without constant second-guessing. There is a clear logic to it. If you judged a new partner with full, cold scrutiny, you might never commit to anyone at all. So the brain quiets the judge for a while. The danger, of course, is obvious. The same silence that lets love grow can also let you ignore real warning signs. People stay in situations they would never accept for a friend, partly because the region that should object has gone soft and quiet. This is not an excuse, but it is an explanation. So picture where you are now. The spotlight is locked. The engine is racing. The thoughts are looping. The judge has left the room. This cannot possibly last forever, and it does not. So what is the brain building under all this chaos, while the fireworks slowly burn down? Underneath the fireworks, your brain is quietly mixing a different kind of chemistry. Slower, calmer, built to last. Its two main ingredients are oxytocin and vasopressin. Oxytocin is often called the bonding molecule. It is released through touch, through closeness, through sex, and it deepens trust and attachment. It is the same chemical that floods a mother holding her newborn. Vasopressin works alongside it and seems tied to long-term commitment and the urge to protect. We learned much of this from a small, faithful animal, the prairie vole. Prairie voles bond for life, and their brains are rich in oxytocin and vasopressin receptors. Block those chemicals, and the bond never forms. A closely related vole lacks the same wiring, and it never settles down at all. Same family, different chemistry, completely different love lives. In you, these molecules slowly take over from the wild dopamine rush of the start. The frantic wanting softens into something steadier. The need to chase becomes the comfort of being near. This is the bridge from passionate love to companionate love, from the storm to the hearth. It is less dramatic and far more durable. Couples often mourn the loss of the early fireworks, not realizing the brain has simply swapped one system for a deeper one. You can feel oxytocin working in small, ordinary moments. A long hug, falling asleep beside someone, holding a hand through bad news. Each of these quietly releases it, and each one tightens the bond a little more. This is why touch matters so much in lasting love, far more than people expect. It is not sentimental. It is the literal mechanism by which the attachment system is fed and kept alive. Couples who stop touching often feel the bond thinning, without quite knowing why. The chemistry was going hungry. The high was never meant to be permanent. It was the glue setting. But that raises an uncomfortable question. If the fireworks are designed to fade, why do they fade so fast? And where exactly does that breathless feeling go? Why does the wild stage always end? After a few months, sometimes a couple of years, the breathlessness quietly drains away. This is not failure, and it is not your fault. It is your brain protecting itself. Remember, early love runs on a flood of dopamine and stress chemicals. Your body simply cannot stay in that high alert state forever. It is exhausting, and it would wear you down. So your brain adapts, the way it adapts to anything intense. The receptors that catch dopamine slowly grow less sensitive. The same flood that once felt overwhelming now barely registers. It is the same reason a song you adored stops thrilling you on the 100th play. The brain turns down its response to keep you balanced. Studies suggest this passionate phase typically cools somewhere between 1 and 3 years. Long enough, in evolutionary terms, to form a bond and perhaps raise a child through the most fragile early stretch. The chemistry was always on a timer. When the high fades, many people panic. They think love has died. Often, what has really happened is that the loud system has quieted, so the quiet system can be heard. The dopamine fireworks step back, and the oxytocin bond steps forward. The relationships that last are usually the ones that let this handover happen instead of chasing the lost spark forever. But this leaves us with one final question, the one everyone secretly wants answered. If the fireworks are built to fade, can real love actually last a lifetime? So can love truly last, or is forever just a story we tell? Here the science offers something quietly hopeful. Researchers scanned the brains of people married for 20 years or more, who still said they were deeply in love. And in those brains, the old reward area, the ventral tegmental area, still lit up at the sight of their partner. The spark had not vanished. But there was a crucial difference. In long-term love, that reward signal came without the anxiety and obsession of the early days. The looping serotonin crash was gone. In its place sat the calm, rich activity of the bonding and attachment systems. So lasting love is not the absence of the spark. It is the spark with the panic removed. The wanting remains, but it no longer hurts. You could think of early love as a fire that roars and consumes, and long love as a fire banked low for warmth through a long night. Same flame, different purpose. This is why couples who stay together often describe a love that is less frantic but far deeper. The storm was never the destination. It was the journey to the bond. And that bond, once built, can quietly outlast the chemicals that made it. So the next time your heart races over someone, remember what is really happening. It is not magic, and it is not your heart. It is the oldest machinery in your brain, doing exactly what it was built to do. So what happens in your brain when you fall in love? A tiny ancient circuit floods you with dopamine and stress chemicals, dims your judgment, fixes your gaze on one person, and then slowly trades the storm for a bond designed to last. Love is not a feeling that happens to you. It is a sequence your brain performs, with a beginning, a peak, and a quiet, lasting end. But your brain has other secrets, other circuits running just beneath the surface. Next time, we step into the dark. What really happens inside your head in the final moments, when the brain begins to shut down? The answer is stranger, and stranger than you would ever guess. This was Doodle Anatomy.